Right. So, this week, Monday, Tuesday, Wednesday, Thursday, Friday, I'm here. We will do some review of derivatives today and tomorrow. Good to see you, brother. Then we have a small little quiz. Then we have 4-5. And then I owe you guys the orange story, so you'll get that on Friday, which is not really real life math, but it's fun. Hopefully you enjoy it. But then, next week, Wednesday and Thursday, I have a district training on this new math curriculum that they're ramming down our throats. Me and there's a total of 17 math teachers that get to go to this training Wednesday, Thursday next week. So I will have a sub. I will record the lesson, post it for you to watch. So come to class or go eat pancakes. Your choice. But obviously, if you're not here, you get marked absent.
Which day?
Wednesday, Thursday next week. And then on Friday, I won't be here. Not because I'm at a district training. I have to do the final walkthrough of my new home. So even though I get to throw up in my mouth a little bit for Wednesday, Thursday next week, because I really don't want to go to this, but they're forcing us to, Friday at least will be that. So just because I like to let you guys know when I'm gone, because I'm not normally gone. So that's what we have. So we'll have a quiz on this day. It's just a one-side sheet of paper. It's not on Schoology, sorry. Maybe I could put it on Schoology. I don't know. We'll figure it out. But that's what we have going. Sound good? So break was good for you all, I hope. My break was, I thought it was pretty good. The nice thing was having that Thursday, Friday off. I got to spend the last 2 days, those 2 days with my daughters who were both back from college. So it was nice to see them and spend some time with them. And that's about it. All right, so I don't remember what I assigned you, what I didn't assign you, but let's see. I think we left off on the, let's see, let me just double check my phone, dates. Where did we stop? Were we on 4.3? You gotta help me out, I can't remember. Worksheet 4-3, was that what we were on? I thought I maybe had done like 1 through 7, but I can't remember and I apologize. That's been like 2 weeks ago, almost 2 weeks ago.
You did 10 and 11.
I did 10 and 11 on 4.3, or I asked you guys to do 10 and 11. I forget. You recall? Well, let's just for the fun stuff, let's take a look at number 10, where they get f of x is equal to x to the 4th minus 4x to the 3rd plus 9. And they want us to find the horizontal tangents to this. So we have the fortunate way of finding horizontal tangents. We can graph the original. So let's just graph the original on Desmos. Hopefully my internet's working at this point. Alright, so let's look at this 2 different ways. So I'm going to go y equals x to the 4th minus 4x to the 3rd and plus 9. So there's basically two locations, and if I zoom out on this graph, we're seeing everything that's taking place. We have this little tiny wiggle spot that happens here. There's going to be a horizontal tangent there, and there's also going to be a horizontal tangent here. So remember, a horizontal tangent means you would have a tangent line that has a slope of 0. Okay? So I think we could maybe click here and click here. So at 0 and also at 3, we have something called a horizontal tangent. Okay? Well, let's see how a derivative would find us the horizontal tangent as well. Okay, so I'm going to go back to this. Does anyone remember how to find the derivative? What's the derivative of x to the 4th? 4x to the 3rd, good. So bring the exponent down front, multiply it by whatever number might be there. In this case, there was 1 there. And then reduce the, subtract 1 from the exponent. And then the minus comes down. What's the derivative of that?
12x squared.
12x squared, very good. And then the derivative of this is just 0, so anytime we have just a number, we're good with it. Okay, so that's the first couple of things. Make sure we're recording good. All right. So, things we want to do. If we want to figure out the horizontal tangent without using Desmos, I'm going to go 4x to the 3rd minus 12x squared, and I'm going to set it equal to 0. Still with me so far? So take the derivative, set it equal to 0. And then, using Algebra 1, factor out what you can. So we're going to get that. Okay, because I have a 4x squared in common here and here, I can factor that out front. And then set each part of that equal to 0. Divide by 4, so that's still 0. Square root, I get 0. And then at x minus 3 equals 0, set x equals 3. So at those two junctures, at 0 in the x direction, hello, good to see you, brother.
It's good to see you.
And we are on worksheet 4.3, number 10. And then we can say, so 0 and 3, is that what we had said on Desmos? I got a 0 there and I get a 3 there. There's where our horizontal tangent lines would be. Okay, pretty simple. And then number 11 says, write the equation of the tangent line to the curve at the indicated point. So let's go on to number 11. Oops. Number 11. We have y equals 5 minus 2 root x. And we want to find the line. We want to find the line, the tangent line at that point. So just know we're going to make our tangent line in this form, which is called point slope. And we can leave it as point slope. Okay, so two different things we could do. We can figure out what our point is, where the point of tangency takes place first, or we can find the derivative and figure out the slope. So let's figure out what the point would be. So I'm going to take the 4 and I'm going to plug it into the original equation. So that means that at, well, hello, gift cards here. Thank you very little. Why'd you get it? What'd you do? So I plug 4 in and I have 1. So at 4 comma 1 is where our point is going to be tangent to our equation. So I'm going to take that, and I'm going to call that x1, y1. So if I took that and plugged it into here, I'm going to get y minus 1 equals m times x minus 4. And so now the second part of this is we need to find the slope. Okay? So we have everything for this line given on the equation. We have to figure out what m would be. So in order for us to figure out what m would be, is I want to take the derivative. But before I take the derivative, I want to get rid of any radicals. So I changed the square root of x to x to the 1/2 power. And now I can go ahead and find the derivative of this. So y prime, the derivative of 5 is just 0. The derivative of this, I'm going to go -2 times half x raised to the 1/2 minus 1. Did you follow the math I just did? Clean it up. This reduces here, so I get -x, and I'll make that 2 over 2. And that's going to become to the -1/2 power. Okay? So that's our derivative. Y prime is -x raised to the -1/2 power. I can now take this value here, and I can plug the 4 in. So I have -4 raised to the -1/2 power. So that's the square root. So this actually is going to become 1 over -4 to the 1/2, which is 1 over square root of -4. So this is going to give me -1/2. This is my slope. Now I have the slope to this, so my equation y minus 1 equals -1/2, x minus 4. This is my equation of my line at x equals 4 that is tangent to our graph. So I'm going to plug this equation in on Desmos to take a look at what it looks like. So I get y equals 5 minus 2 square root x. So this is our line. I think I did that right. Let me get rid of that. Let me get rid of that. No. So y equals -2 root x. Got it? And then I'm going to go y minus 1 equals our equation -1/2 x minus 4. So there's my point 4 comma 1. That's the point in which it's tangent. If I zoom in on this, the green is our tangent line. Remember, a tangent line touches our graph exactly one spot. And so right there is our point of tangency, and that shows us that we have that linear equation that takes place. Okay? All right, let's try one that we don't have as a graph. Let's say this is an example. Let's say I had an equation that looks like this. Square root of x plus 5 over x to the third. Okay, so if I wanted to find the derivative of this line, I'm going to clean it up. I want to make sure you understand where all the values came from. So the square root of x changes to x to the 1/2 power. The x to the third in the denominator, you move it up to the numerator. When you move something with an exponent up, it becomes a negative exponent. And then from here, I can easily find the derivative. So I get 6x, okay, to the first, plus 1/2 x to the negative 1/2, because if I subtract 1 from half, it becomes negative half. And then this becomes minus 15x minus 4. So things to remember. Subtract 1. In this case, it's equal to 2/2. Subtract 1. And subtract 1. Okay? So this is our derivative of that particular graph, or of that equation. Okay? Some math classes will want you to clean it up. I'm totally happy if you leave it dirty. If you wanted a cleaned up version of this, it would look like this. This is the cleaned up version. If you were in Calc AB, they'd expect you to have the very bottom. You're in Business Calc, so you get to leave your derivatives dirty. You don't have to worry about cleaning them up. Leave them dirty, you're totally fine. It's up to you if you want to switch it. I would leave the dirty answer first in case you make a mistake, but I will give you the full points here. I would say leave that as at least for your answer. If you try and convert this and you make an error, as long as you have this answer here, you're going to get it right. That makes sense? So a dirty derivative. All right. So, will you try this one? Let's say I have y equals 3x squared plus 2x, and I x equals 1. Find me the equation of the line tangent to the given equation at x equals 1. See if you can figure that out. Give you a couple minutes to give that a shot. Hey! So, good to see you, brother. Good to see you. Give that a try. See if you can figure it out. I don't care where you squeeze it in. Write it on your desk. Make my freshman in Algebra 1 go, what is on my desk? yellow highlight is the answer. Did you get it? Questions? You good about it?
Where'd you get the 5?
Where did I get the 5? Oh, okay. So I'm going to take my original x equals 1. And I'm going to plug it into my original equation. So I get 3 times 1 squared plus 2 times 1. So 3 times 1 squared is 3. 2 times 1 is 2. 3 plus 2 is 5. That gives us the point 1 comma 5. So that's on the original. Then you take the derivative and you take the x equals 1 and plug the 1 in for the derivative, and that finds you the slope at that indicated point.
Okay.
We good? Everybody happy? So my plan is a small derivative quiz on Wednesday. I think there's 8 questions total, I believe. But I want to give you some time to review. And I might actually put it on Schoology. I haven't figured it out yet if I will or won't. But if I get it done between now and Wednesday, we might do it. So I'll let you definitely know tomorrow. So on Wednesday you can bring your computer, but you can also do Schoology on your phone too, right? So let's have you guys work on 4.1 to 4.3 practice quiz. And will you do just the front page? And we'll go over that tomorrow. Cool? Everybody happy?